In this problem, we need to prove that the cross product between vector A and B is also given by this particular expression as shown on the right hand side. So let's begin. So first, let us consider the vector I. This is the first term that we're considering. We have the vector I cap crossed with vector A dotted with vector B. So by definition, this is the scalar triple product between the vector I cap, A vector, B vector. This can be also expressed that we have I cap dotted with vector A cross B. Means exactly the same thing. Now we have I cap. So I cap can be also expressed as the vector cross product between the unit vector J and K. So we have used J cap cross K cap instead of I cap. So this will be dotted with vector A vector cross B vector. Now what we have here is the scalar product of four vectors. Now we can use the identity A cross B dotted with C cross D, which is given by this 2 by 2 determinant, to evaluate this particular scalar product of four vectors. So we will have J vector dotted with vector A. We have J vector dotted with vector B. Then in the second row, we have K vector, K cap dotted with vector A and K cap dotted to vector B. J cap dotted with vector A. This means we are talking about the Y component of vector A. So we're representing with A suffix Y. J cap dot B vector, that is the Y component of vector B. K cap dot A vector, so we're talking about the Z component of vector A, and K cap dot B vector is the Z component of vector B. Now when we expand this particular determinant, then this is going to give us AY BZ minus BY AZ. So that means we have obtained, let's write it down, I cap cross A vector dotted with B vector. So this is equals to AY BZ minus BY AZ. And this is also, if we take the cross product between vector A and B and consider its X component, so this is going to give us AYBZ minus BYAZ. So let's call it equation number 1. Next, what we'll do, we'll look at the second term. In the second term, we are given J cap cross A vector dotted with B vector. So this is the same as saying with the scalar triple product between J cap A vector B vector, which is the same as J cap dotted with A cross B. J vector is simply K cap cross I cap dotted with A cross B. And if we used the scalar product of four vectors, then this will be K vector dotted with A vector. Then we have K vector dotted to B vector. We have I vector dotted to A vector and I cap dotted to B vector. So K vector dotted to, this is K cap. The unit vector K dotted with A vector gives us the Z component of vector A. K vector dotted with B vector gives us the Z component of vector B. I cap dot A vector, so this is going to give us the X component of vector A. I cap dot B vector gives us the X component of vector B. So that means we have AZBX minus BZAX. And this is also, if we take the cross product between vector A and B and consider its Y component, then this is also going to give us AZBX minus BZAX. Then similarly, we can say that K cap crossed with A vector dotted with B vector. So this is going to give us A vector crossed with B vector, and we will have the Z component. We have now I cap crossed with A vector dotted with B vector multiplied to I cap plus J cap crossed with A vector dotted with B vector times J cap plus k cap crossed with a vector whole dotted with b vector times k cap. So this will be equals to, so we have the x component of a cross b, the x component of a cross b times I cap plus the y component of a cross b times j cap plus the z component of a cross b times k cap, and this is nothing but the vector a cross b. So that means we have successfully shown that the vector a cross b can be also expressed in this particular, the sum of these three vectors.